rotated digits. An integer x is a good if after rotating each digit individually by 180 degrees, we get a valid number that is different from x. Each digit must be rotated. We cannot choose to leave it alone. A number is valid if each digit remains a digit after rotation. For example, 0, 1, and 8 rotate to themselves. So these are not good numbers because it has to be different from x, from the number that we started from. So this would not be considered good numbers. 2 and 5 rotate to each other. In this case, they get rotated in a different direction. In other words, 2 or 5 gets mirrored. 6 and 9 rotate to each other, and so these are good numbers. So, and the rest of the numbers do not rotate to any other number and become invalid. Given an integer x, return the number of good numbers in the range 1 to n. So here we can see that we have example 1, and we're given n, which is 10, and the output is 4. So we have 4 numbers that are good here. So that's why we have 4. There are 2, 5, 6, and 9. So these are our good numbers. And example 2, we're given 1. We have no good numbers, so we got a 0. And example 3, n is 2, and we have 1 because 2 is a good number, and that's the only good number from 1 to 2. So now we can solve this with we can make a set and then make a function to see if it's a good number, and then make a loop to go through the range that we have of numbers and then add to the good numbers count. So let's make our sets to hold good and bad numbers. It's called good numbers will be equals to, let's put 2, 5, 6, and 9. Bad numbers will be equals to so these are not, we don't also, so the numbers that are not these are these. So our bad numbers, we can also put these, but there's no need to. We can just put the numbers that we don't have listed. So let's just put 0, 1, no, 0, 1, 2, 3. Let's put 3, 4. We have 5, it's no good number. 6, we have 6 in it. 7, 8 is already 9. Hold on. We have 9 inside. So these are our bad numbers. So now let's make a function. Check if good or bad number. If a number is good or bad. So let's go to def. Let's call it is good. Is it good? Let's call it is it good, and then let's put num. So let's check. Let's make is it different? Different. So let's make it false for now. So let's go to for I, for num, no, sorry, for digit and num. This makes num strange. Num, if the digit is in, if the digit is in bad numbers, return false. If digit and good numbers, let's make good numbers equals to, hold on. So let's make is different. It will be equals to true, and then return true, but it's different. It's different. So now let's make a good number count. So let's call it good numbers count. So let's make a loop for I the in the range of 1 to n plus 1. It shows it that here return the number of good. So if good if is it good is if it if it is, this should be it is, where is it also makes sense. Let's put I in the parameter and good numbers count plus equals to 1, and then return good numbers count. So let's see if we have any syntax errors or any mistakes. Oops, found one already. This should be set to 0 to start from. So for I in the range of 1 to I, and that should work. Let's see if it does. And it's been accepted. So our time and space complexities. Time complexity is O of O of n. Our space complexity is O of 1. And that's it for this problem. Let's submit it to see if it's going to pass all cases. And it's been able to pass all cases.